Okay guys, today I want to talk about couples. Now this is when two forces of equal magnitude but at anti-parallel on an object they tend to cause rotation only. So, couples, when two forces of equal magnitude but act anti-parallel on an object, they tend to cause rotation only. So let's imagine we've got a simple beam like this, and maybe we've got two forces, one acting in this direction, and it's going to have an equal magnitude, so it's going to be the same size force but act in the opposite direction or anti-parallel. Now what's going to happen if these objects would tend to cause this to rotate around? So for example, my little pen here, it will just tend to rotate around. Going to turn around like this. Now, there's going to be a central point about which the object will rotate. It's going to be here. So what we're going to apply is the idea of moments around this pivot point here. Now we need to just think about this distance here, so the length of the beam we are going to call S. Now the distance from this force to here is half S, so that's the distance here to here. Likewise, here is also half S, distance from here to here. So this force here is causing a moment around this point, and that moment has got a value, well, it's the force times the perpendicular distance. So it's going to be a half times F times S. Likewise, this force over here is also going to cause a turning effect or a moment about this point here. And that also has the same value, a half F S. So any couple, if we add these up together, we'll find the total moment produced by a couple is the force produced by one of the forces times the total distance S between the two forces. So this is, so F, actually let me change the colour. So F is the magnitude of one of the forces. In the couple. So F is the size of one of the forces in the couple. S is the distance between the two forces. So let's have a look at an example. So maybe we've got a beam. Okay. Now the beam, maybe there's a force of 10 newtons here and 10 newtons acting anti-parallel over here. So this is going to cause a rotation. So we need a distance between the two forces, and in this example we're going to make that 1.2 meters. So what is the total moment being produced by my couple? Well, we've got one of the value of the forces here. Remember, they're equal in magnitude, so I can take either one, multiply that by the distance between the two forces. That is going to tell me the value of the moment around this beam. So let's just apply our equation, Fs. Well, in this case, F is 10, S is 1.2 meters, which is going to give us it's going to give us 12 Newton meters.